Alright, this is lesson 6 and lesson 7 kind of combined because they're very closely related to each other, and they involve the how to do polynomial division and then how to use something called the rational root theorem. So the first thing is we need to understand when we have polynomial division. There's three ways you can see a division problem written. Actually, there's a fourth way, the way we actually write it to carry out the division. But the first one is, you can see we've got a polynomial. This is a quadratic trinomial, and it's divided by a binomial. And all three of these cases are the same problem. But we can write it here with a division problem. We can use a negative exponent, a negative 1 exponent on the x plus 3, indicating x plus 3 should be in the denominator. And in this last method, it's actually written in the denominator, so it looks like a fraction. Okay, but all of these mean take that denominator and divide it into the numerator. In some cases, this is easier than others. The simplest case of polynomial division involves problems like this. In this division problem, what we have is a cubic trinomial. So we got three terms, and the highest degree is 3. That makes it cubic. But it's divided by a single termed polynomial, which is a monomial. When you have a problem like this, the simplest method to simplify it is to take each term of the numerator and put it over that denominator. Okay, so we've just written them all over that common denominator. So we've kind of unadded the fractions together. So I've taken each term and written it over that denominator. And now, because those are terms over a term in this case, all of our laws of exponents that we've been using apply, and we can just simplify each term individually. So in this case, 12 divided by 4 is 3. The k's will cancel, and using exponent subtraction, I get m squared, 3 minus 1. Next, I have a minus sign. 20 divided by 4 is 5. Exponent subtraction there, because I'm dividing. I get k to the first power, and the m's cancel. And the last term, 18 and 4 are both divisible by 2, so that's going to be 9 halves. I'll end up with a k in the denominator and an m in the numerator. And so that would be the simplified form of that division problem. So it's relatively simple to accomplish. Now, this only works when you have this monomial, one term down there. As soon as we have a binomial, plus 3 or some other term added onto it, making it a binomial, we can no longer use this method effectively. Okay, so let's look at when we do have something other than a monomial in the denominator. Here's the division problem that was given at the very beginning, so let's write this as a division problem now. X plus 3 divided into 2x squared minus 4x plus 3. So now that we have it set up like a long division problem, we just go ahead and kind of work through it just like we would with regular division. First thing you want to ask yourself is, what do I have to take x times to get the first term into the dividend? In this case, 2x squared. So I got to take it times a 2 to get a 2, and another x, so that when I multiply 2x times x, I get 2x squared. Okay? So now that I've figured out what to multiply by, I actually take that 2x times my divisor. So 2x times x is 2x squared, and 2x times 3 is 6x. And then, just like in long division, I have to subtract. So I've got, let's grab a highlighter so you can see kind of what I'm thinking here. Make it kind of a yellowish color, hopefully. There we go. So I've got 2x squared, and I'm going to subtract 2x squared. So that gives me 0. And then I've got negative 4x, and I'm subtracting 6x. And so there I get negative 4x minus 6x, which is negative 10x. And then I bring down the next term. Now I ask the same question, what do I have to take x times to get negative 10x? The answer is negative 10. And then I take that negative 10 and distribute it to my divisor. Now negative 10 times x is negative 10x. Negative 10 times 3 is negative 30. And I subtract. I get negative 10x minus negative 10x, which is negative 10x plus 10x, that's 0. And I get positive 3 minus negative 30. And that's a double negative, so I'm adding. I get 33. I can't take x times anything to get a 33, so that is my remainder. Now we normally don't write it as remainder 3. What we say is this polynomial, if I were to simplify it by carrying out the division, is 2x minus 10 plus my remainder, 33, or just a 3 there, over my divisor, x plus 3. And so there is what it is equivalent to. There's a check for that. I mean, you could take your divisor x plus 3, multiply it by your answer, and you will get the original polynomial. Now we aren't doing this just so we can divide polynomials. There isn't a whole lot of sense in just doing that for the sake of doing it. What we're trying to do essentially is find out whether x plus 3 was a factor of the original polynomial. And we can see in this case it's not. If it's a factor, it would divide into it evenly. Because we've got a remainder, it's not a factor. Okay, let's do another one of these things. Here I've got it set up as a fraction, but we're going to carry out the division. Now this one you have to be a little bit careful on. So my divisor is x plus 1, and I'm dividing into x cubed plus 3. When you set this up, you've got to make sure that you put in space holders for the terms that are missing. In other words, I've got 1x cubed, but I don't have any x squared, so I want to put that into my polynomial. I don't have any x terms, so I'm going to put in a spacer for that. I do have a constant. So there is the setup for my division. And now let's walk through it. Okay, to get an x cubed, I've got to use an x squared. And so x squared times x is x cubed. X squared times 1 is x squared. And you can see why I had to put in that 0x squared now. What that's allowed to happen is for like terms, x squared terms, to line up. So I've got 0x squared, and I'm going to take away x squared. That's negative x squared, and I bring down the next term. Next I have to multiply by negative x, and I distribute that, and I get negative x squared minus x, and I subtract that line. The first terms cancel out, the next terms give me a plus 1x, I bring down the 1. And to get x, how many x's do I have? What do I have to multiply x by to get x? The answer is 1. I distribute that 1 to both terms of the binomial, and I get x plus 1, and I subtract, and I get 0. So in this case, I did not get a remainder. And the division problem has an answer of x squared minus x plus 1. You erase the work for this. Let's discuss why that was not a big surprise. If I look at the original division problem that I had, up here on top I have a sum of two cubes, and we should know how to factor that thing. It's a plus b, x plus 1, times x squared minus ab, or I guess a squared, in this case x squared, minus ab, which is 1 times x, plus b squared, 1 squared, divided by x plus 1. So that's what the original problem was if I factor the numerator. And you can see that x plus 1 is a factor of the numerator and the denominator, so essentially I divided that out when I did my long division, and I was left with the remaining factor, x squared minus x plus 1. So you can actually see that x plus 1 was a factor of that numerator. That's why it went into it evenly. The next thing we covered also was the rational root theorem. The rational root theorem says if you do a division problem take some polynomial and divide it by x minus a, you will end up with a remainder whose value is the f of a. And to demonstrate this, I'm actually going to come back here and we will actually look at this division problem again. X cubed, let's see, it was x cubed plus 1 divided by x plus 1. When I carried out this division, I got x squared minus x plus 1, remainder of 0. And what the remainder theorem says is that if my function, in this case x cubed plus 3, were divided by x plus 1, that the remainder would be the same as the value of the f of negative 1. Notice this says a minus b, or x minus a rather. So if I follow that formula, x minus a, I can see that a would have to be a negative 1 to give me a x plus 1. So if I were to plug this negative 1 into this, I get negative 1 cubed plus 1, which is negative 1 plus 1, which is 0. Exactly the remainder I got when I did the division. Let's look at another example of that. Let's say I've got x squared plus 2x plus 1, and I wanted to divide by x plus 2. Okay. One question often asked is, what's the f of negative 2? Well, one way I can do that is I can plug negative 2 into my function. Negative 2 squared is 4, plus 2 times negative 2 plus 1. That gives me 1. The other way I can answer that question is to do the division of x plus 2. Go x, that gives me x squared plus 2x. Subtract that, bring down the 1. Goes in there x times with the remainder of 1. That also tells me the f of negative 2 just by looking at the remainder. Now this has lots of implications. One primary one is answering a question like this. Is x plus 4 a factor of x squared minus 5x plus 8? Well, one way I could test to see if it's a factor is I could actually carry out the division. I could go, hey, x plus 4, do you divide evenly into x squared minus 5x plus 8? But that long division takes a little bit of time. So another option for me is to say, hey, if this is a factor, then the f of negative 4 should be 0. And so I'm going to plug negative 4 into the function, and I'm going to see if it gives me 0. That's 16 plus 20 plus 8. That is nowhere close to 0. That's 36. That's 44, I think. Since the f of negative 4 does not equal 0, I know that x plus 4 is not a factor of this polynomial. Had my remainder been 0, then x plus 4 is a factor. Alright, hopefully that will help you get through your homework. Your homework is listed on the website. I'm going to see if I can grab it quickly so I can pull it up and tell you in case you were gone from class here. There we go. It's Unit 3, Section 6. So that's a unit we've been working in. Section 6, and it's 156 through 163. I'd work through each one of those problems because they asked various questions, including questions involving the remainder theorem.